Hi, I'm Sam Louis, SkreetKar 3D. Today I'm going to be demoing the new Revopoint Trackit scanner. It's the new laser scanner that's coming out from Revopoint on May 28th. Um, Look at the description of this video and you'll see the link for the Kickstarter. The Trackit device actually is a secondary scanner. It's actually off frame right now. But today I'm going to be demoing how to use the scanner and how we're going to scan an automotive part. This is a 1968 Mustang bell housing. Just an old one that I had laying around. It's kind of a little dirty and grungy, but I think for scanning purposes, we'll be able to get a good reference. I got it kind of on a glass Pyrex dish right now. That's just simply to elevate it off the ground. I'm going to go ahead and start a new scan. Now we should be able to rapidly scan this. It's not really a dark object. It is shiny in certain parts because it is cast aluminum. The outside looks like it's either oxidized gray or someone spray painted it gray. Don't know. I wasn't the previous owner of this. But the inside is kind of just raw cast and it's got some sheen to it. So let's go ahead and try to see if we can scan this really quickly with no tracking, with no markers, and no scan spray. All right, so let's go ahead and grab the scanner. Now, this is a Lenovo Legion 5, 5i Pro, something like that. Um, I am using two video feeds, displaying on a 50-inch 4K monitor, and then I'm also scanning for this demonstration. For those purposes, I actually bumped the target point distance to 1 millimeter. Note that that does nothing for the quality of the scanner. It's still completely capturing in full resolution. That point cloud distance is simply just what it's rendered on the screen, what you're viewing, and what I'm actually trying to capture for my reference. And we can always still mesh below 1 millimeter. So that's just a disclaimer. Okay, so before I just keep talking, let's go ahead and go straight to it. Now, if I do lose tracking around this area, please understand that I am blocking the scan it device with my arm, okay? So I'm going to have to kind of get a little slick and kind of walk it in, but the rest of it, it should completely keep scanning just fine. So just know if it loses slightly some tracking there. It has nothing to do with the tracking system at all. It's just simply I'm an obstacle. I'm actually a little too close right now. I'm limited in scanning space because it's raining outside. Again, like my older videos, and I cannot kick these vehicles out in the rain. So, all right, so let's go ahead and try to get this scanning. As you can see, it's just picking this up like instantly. And see, it tried to lose tracking just a little bit. I'm going to move out of the range. Now it should be seeing this completely fine and continue tracking. But now I'm going to hit the zoom button on the back of the scanner, and we're just going to color this in. And it's scanning beautifully. Now I am planning on scanning this in two parts, and we're going to do it on the video. Since this is raw aluminum, I don't think I need to scan this with like 20,000 frames or anything like that. Now that little blip that you just saw right there, that was because I'm actually blocking the Trackit with the actual bell housing. So I'm going to keep trucking. Yeah, it's working instantly. You can see we're tracking just fine. I'm gonna hit that side. Okay, we're just going to town with it. I just walk it in. We'll get this flange nice and green because that's the most important part of this entire bell housing. It's that flange. If you're going to reverse engineer like a replacement bell housing or need the mounting points, that's exactly where you're going to try to focus all your attention. The rest of the bell housing, that's kind of simple. I mean, that's just making sure you clear um, the torque. Yeah, I just want to make sure, yeah, the torque converter, but the rest of it, it's essentially the flanges and the distance between the two flanges. But, yep, we're filling this in nice, and I'm just going to slowly walk it in. You can see we're already at 85 or 84,000 frames. It's just eating it up. It has no problems losing, it's not losing track at all. Now, there is some corrosion on that portion of the bell housing, so I'm pretty sure that's just why that's not scanning. So I can solve that. Right now, I'm at default shiny mode. I'm gonna bump the gain just up just slightly, and that should pick up. Okay. And we're just gonna slowly fill this in. You want to be able to scan this entire item green. That's the only way it's going to get all the amount of points it needs to fill in this point cloud. Okay. All right. Now I'm just going to make one more pass about this flange. A little too close. I'm going to back up. I'm just trying to get as much of this as possible. I'm satisfied with that. Let's go ahead and zoom out. Oh, look at that. Beautiful, nice and green. And honestly, if I would have kept at it, I'm pretty sure I could have got the rest of it. But if you see, it's kind of thin right here. I am elevated on a glass bowl. So I am satisfied with that. I'm not sure what's going on right there. I think that's probably just some, um, I think it's probably just where the anodizing, or excuse me, corrosion is just flaking off a little bit. If you really wanted to go back over that section, we can. So it's just on the right of that. Yeah. I'm satisfied with it. I don't think we need to worry about filling that in. I'm pretty sure those are probably good point data. I do, however, think I can get some of this portion a little bit better. That portion. Focus on internal lip of that flange. But all right, we're sucking up frames fast and furious, and I don't want to do that. So yeah, now this is nice and green. So what we're gonna do is we're gonna mark complete, and then we're simply gonna flip it. Okay, I'm satisfied with that. Now let's go ahead and flip this and scan this side. And actually, I think I can take this bow out, and we'll just chop. We'll just chop that wood piece off. I'll try to put it on a place where there's not a lot of bolt holes or anything like that. Looks like that's bridging between two bolts. It's kind of tippy topsy. Let it level off. And we're going to go ahead and create a new scan. Okay. Now, I think I'm probably going to need to move this Trackit device just down just a smidge. If it loses tracking, I'll just restart and then readjust the Trackit. But I think we're okay. Let's go to town. Yeah, beautiful. And a zoom in. You saw what happened. That fell down. So let's just go ahead and cancel that. Hey, yeah, that's going to be in the blooper reel, but I'm not going to start over. Okay, so let's go to town. Let's just try to get this done now. Before anything else happens, besides the fall off, you start to lose power from this rainstorm. Zoom in. And like I said, you're just going to color all that in. You're just wanting to get everything. And again, I'm blocking the Trackit. Everything nice and green. So I'm going to focus on that portion of the bell housing. And as you see, I'm kind of waving a little crazy. I should be going nice, smooth transitions. But yeah, a little crazy on that. So go ahead and get that inner lip right there. The back of that little mounting point. Okay, we're gonna keep on getting that inner lip. And that's just gonna help us with alignments later. Okay. Now I want to try to get this portion nice and flat. This is looking nice and green. I'm gonna keep going. This is where the starter comes out. So that's probably the most important portion of the bell housing, is that starter portion. Okay. All right. Getting wrapped up with the cable. See, we picked right back up. And then you see it's picking up just fine. Try to get that portion. Try to get this bottom lip. Okay. Now it's always good to check your work. Let's go ahead and see. We're only at 6,000 frames, so that scanned it nice and quick. So we're not loading down. I can go over this portion right there. Okay. And I think if I went over here, I would get all that. So my arm is blocking. But I think it's going to get that portion just fine. So slowly walk it in. It's probably the most important part, is if you're close to the Trackit, just take your time with it. It'll get it. It has to have enough of these points to reference. So, see, I'm walking. Sometimes if you twist the scanner, it has enough points of reference to get in there a little bit better. We're just going to keep scanning. Turn it around. Go back to an area you've already scanned. And just see about getting that flange nice and painted. See how I'm kind of exposing more of the scanner to track it and keeping track. All you really need to do, you just need to present a nice area for the scanner to scan. And then I'm just gonna give it a nice clean pass. Just have extra point cloud density right here. I'm just going to go around it. I'm more concerned about this bell housing. I mean, the starter location, because I think that's going to be, if you were going to use that bell housing and you were going to use these point references, that would be what I would focus on. Okay, 13,000 frames. Zoom on out. Let's check what we got. I think that looks pretty good. So let's go ahead and complete the scan. And we're going to go ahead and try to see if we can just make a complete watertight STL. So because we're scanning, we're doing it live. I'm not going to try to do like I'm not going to try to do point 1 or 0.15 or anything like that. 0.35 is going to be perfectly fine for this type of mesh. You're still going to get your accuracy. You're scanning with a laser. You haven't lost track. You haven't missed tracked. And you're getting a round surface. So as long as these points are in the correct location, I can definitely load that into my CAD and hit the ground running. So let's go ahead and let this process. Now, I would recommend scanning in multiple angles. So like now I've scanned it here. I would probably turn it 180 and scan it here, because you're not always going to get every single angle perfectly fine. I have, this bench here, so I'm kind of limited with my scanning ability here. I have a little bit more freedom of movement at this angle, okay? So for me to counter that, I would just flip it over. Same with on the other side. So just don't be afraid to go back and scan. I would recommend doing multiple scans than actually trying to get this all in one go. So like how I had it upside down right here, and I was trying to get underneath here. Cool, you can do that as long as you don't lose tracking. You're fine. If you get it high enough, you probably get most of it, but you're never going to get this bottom of the flange because everything's line of sight. So keep that in mind when you're trying to get the scanner going. Keep scan any object, whether it's near infrared, blue laser, track it, marker mode. Take it in small chunks, because if you're doing too much at the same time, you're gonna, well, worst case scenario is it's too much data, and when you go to process, the application crashes and your entire project file is corrupt. Number two is because you keep scanning over the object, you're continuing to add minute mistracks, like 0.003 millimeters off, because you keep scanning over the areas and it could have just picked up bad data. And then you're also adding noise. Yes, dense meshes are going to be helpful because you're going to decimate that, but you're also creating noise. You want to color this screen and move on. You're not going to super green. It's not going to turn blue on you just because you keep scanning it. So just mind that. Now I did have a 1 millimeter point density, so I did fill in a little bit quicker for our reference. If I had it in 0.4 to default in shiny mode, I think it's 0.4. We would have been there probably another couple thousand frames to get it all green, because what it's doing is it's going, oh no, you may have this little area that's still not completely filled in. And as you saw, I have this, I bet you that's what it was. So that area that I wasn't scanning right, looks like it had a bunch of dirt right there. So that's probably where, but this is a round surface. That little spot, I have no problem doing whole fill. So that's not going to affect the quality of the mesh. Or is it worth keeping over scanning? No. Because now we just proved that I'm over scanning dirt. Yes, I could have cleaned it up. Do I need to? Not really, for the demonstration purposes. Okay, so here's that first, this is the second scan. Looks pretty good. Okay, I'm going to go ahead and process the second one. Same fusion. Now, if you're going to be doing this in batches, a bunch of scans of the object, different angles, like prop it up like this, and then scan, like prop it up with something to support so you can get on both sides. That's what I would recommend. If you're going to do all that, you want to fuse with the batch tool. So you would come over here, and select that. And what you can do is go ahead and set your point down distance. You can decide 3.5 is not going to work for me. I'm not recording a stupid video. I'm going to go ahead and do full send and do 0.15. Well, you can do that. Go eat, go have a beer or something. Come back in probably like 45 minutes to an hour. 2 or 3 of these scans, as long as you're under like 20,000 frames, it should be done in like 30 minutes. So you'll come over here. You still have to do isolation. You'll still have to do overlap, but at least the fusion portion, the heaviest, the longest time to process, those functions will actually be done. That's helpful. So that's what I would recommend. If you're going to be getting the absolute best quality that you need, let it do it on its own time and then walk away. But on this video, I'm not going to do that because I can potentially just set this up for, it could have took 30 minutes and the video would have been way too long. We've already finished one. I say we've probably got another minute on this one, and then we can start doing cleanup. I'm confident that we probably, just with those 2 scans, we have enough data to merge and then just fuse. So that's what we're going to attempt to. Now I am doing add 0.35, which is still good. I think still gonna give us a really clean mesh. And to be honest, there's not a lot of details here. It's not like I'm trying to pull out part numbers or anything like that. I'm going to be more focused on this flat, the flange flatness, which it's covered with corrosion, so it's not going to be flat. So I can feel the texture. This is not going to be flat. I should have probably went over it with some sandpaper. I actually didn't even pay attention to it. You can see the corrosion just coming off on it. I thought it was flat on this side. I think probably I was focusing on this side, so that was my fault. I could have probably yeah, the corrosion's just blowing off right now. Sorry, I should prep better. Prep's important. If you're gonna scan an object, get it as clean as possible. I'm willing to bet no one needs a 1968 bell housing. They only made like 2 million of those. So, and that's, but this is I just had it available, so we're just gonna do a scan demo with it with the new scanner. Let this finish. Now the Trackit scanner for right here, I'm touching it. It's just off frame. Later, I'll probably demo scanning one of the vehicles, but right now, I'm just going to focus on small parts because we are using prototype software, still beta software, and it's still a beta scanner. Okay, so now that's completed. Let's go ahead and look what we got. Nice and crisp. So I got a little bit right there that I might have missed. Okay, well, that's fine because we were scanning like that. So I was scanning that and we're going to flip the other one. So that's fine. So we've already did fusion. Let's do isolation. Let's just do default. Default's 15. Normally I bump it down to like 10. But you see all these floaters, all these stragglers and floaters that it went ahead and captured that. So let's go ahead and do apply. And cleaned it up. And you remember that area that I was worried about? Don't look like it's a problem. So I was chasing ghosts. That's where I'm at. Sometimes it's just better to stop where you are and keep trucking. So there we go. We got that. Now let's go to this guy. Fusion's complete. I'm going to do isolation. Same default isolation. Let that finish. Okay. All red. Okay. Nice and clean. That looks good. And remember that part I was worried about? Well, it makes sense because it was directly underneath it. I wasn't going to get crawl on the ground to fill that in. Okay, so on this, let's get a little fancy. I'm going to have to chop that bottom off. Okay. I want to go ahead and see the piece of wood all together because we know the wood should be somewhat flat and the mesh should be somewhat flat. And we're going to use this clipping tool. I don't like that. Nope. Let's go ahead and escape. Okay. Okay. Oh no, I selected the wrong. No, you just revert, delete. Now let's see what we got. Still got some junk right there. I'm going to see if isolation will pick up some more because I did chop. I might have some leftovers. Okay, pick that up. Didn't quite capture what I wanted it to capture. This is where elevation would have been the key. I did elevate it to that, but obviously it still caught some junk, so we can just do no. Use this tool. Okay, and we got a little bit right there. I'm gonna zoom on in. I can probably. Now, mind you, I should have this data that I'm deleting. I should have that from the other scan, but we're gonna should be careful. Okay, delete. Remember, this is still point clouds, so we're not modifying the mesh yet. That's one side of the wood. Now let's go over here. Okay, let's try to get the big chunk out of the way. Okay, delete that. I'll do isolation again. Okay. I didn't see what it picked up on, but we should have been able to pick up some more junk. Okay. I'll do isolation one more time. And these holes were filled in, so just keep that in mind. Yeah. Those actually ain't holes, those are actually little divots. And that noise you see right there, that's that uneven surface. So, not a clean scan. Not a clean object to scan, excuse me. All right, now we're going to do overlap. Overlap's going to pick up anything that I've actually, these little floaters, great. Okay, let's bump this up. Picking it up some more. Bring that way up. Pick up all that noise. Basically going to keep on going until I see it pick up junk or it yells at me. Now I'm going to do isolation one more time. Okay, gonna bump up that like insane. Okay, gave me an error. Refresh that. Detect. Okay, great. Now that one's done. Now we can focus on this guy. Remember, I only did isolation. I'm going to go ahead and do overlap. Okay, it found that junk area right there. Let's go ahead and bump this up. Okay, that looks good. I'm going to go crazy with it. It's pretty give me an error right now. Nope, it picked up a little junk. Now it went back to the default. Nothing. It yelled at me. Now let's go do isolation one more time. Okay, that looks good. Now we're going to go ahead and bump it insane. Like if it found something, I think I should have done 100%, but oops. All right. So it didn't find anything else. So now we're ready for merge. So I'm hoping that we have enough overlap, which we should, that this will actually be able to feature alignment. So I'm going to do a preview, and preview of that should go ahead and find what it needs to do and align it. I think I have enough data. I'm going to be surprised if it doesn't have enough data to align with that. And boom, great. So The blue is one scan and yellow is the rest. So remember that area that I chopped off? Well, it was able to fill that in, and you've just sat there and merged this completely. So since I'm actually, give me 1 second, I'm going to take a screenshot of this. Okay, and I'm going to do it just right there. Okay. Okay, so that was just a preview. Now it's going to do a generate. So the preview just quickly aligns it as best as possible, but it doesn't necessarily say it's going to actually follow the line. So merging takes longer because what it's going to do is it's going to finally try to merge them together. Okay, so if you have a slightly miss, it's going to verify and it's going to do the processing for you instead of doing a manual alignment. But to be done shortly. Now it's just fusing. This is not a merge of the mesh. Wow. I'd say that looks pretty good. What say you? Okay. Yeah, I'm pretty satisfied with that. Yep. It has a thin lip right there. And there's a little lip right there that's catching on, so I'd say that's pretty good. Now, what we can do is we're going to go ahead and go into isolation. We're going to go to the merge portion. This is that merged file. Okay, we're going to do overlap. Do the same process. There we go. It's got some overlap that I picked up. It makes sense because I did scan the bottom of it. Okay. So we aligned them. So you're going to have more dense noise in that certain section because we did do alignments. I'm going to go insane with it. It should find nothing. Well, found something. Now I'm going to do defaults. You see the software is quick. And we can go ahead and process that. I say that looks pretty good. And this is still point clouds, okay? But keep that in mind. It's still got point clouds. It has a little noise right here, but that was me shooting it in there. And remember, I had a glass bowl, so it was probably hitting that glass bowl and reflecting back. So I'm not too concerned with it. For my use cases, it's actually 100% fine. So overlap. I thought we were doing, I thought I was doing overlap protection. Detection. No. Okay. Didn't find any overlaps. Okay, it did find some right there. I'm gonna go crazy with it and overlap way up here. And this is just cleaning it up before the mesh. I'm gonna do isolation one more time. Picked up some more noise. Yep, yep. And like I said, I think we have a little bit of that table left, so we're good. We're gonna detect that. Okay, cool. All right, so I think we're ready for meshing. Again, remember that noise right here was actually from, the two pieces. So I'm not going to do 6.5. Let's go ahead and do it to like let's do 5.5. Just because I want to be able to do this quickly. I don't want to sit here and wait 12 minutes or something like that. So let's just do 5.5 and see how this actually looks. Because I don't have any markings. I don't see any like major marks or anything like that. So let's just do this so it can finish and we get this video done. This is really just a demo of how they use the scanner. Aren't you glad I didn't use 8? It, it does take a bit. Now, to be fair, it would process a lot quicker if we weren't running so many applications right now. Okay, there we go. Okay, we got a little bit now. You did see, yeah, that looks pretty good. Yeah. So that's been cut. So that's why that's got a little bit of noise right there. So I think it's this one. Okay. These are raised, but that one looks like someone grounded all. Okay. I'm super satisfied with that. I think that's a pretty nice and quick mesh for a dirty bell housing. Okay. Well, again, this is SkreetKar 3D. Hope you enjoyed my scanning tutorial and hope you're interested in backing this scanner. Again, this will be coming out on Kickstarter on May 28th. You can like this video. The link for the Kickstarter should be in the description of this video. Hopefully you were able to get in on the Kickstarter's early bird. I think it's like 35%. 35% is not a small chunk. So think about that and see you guys later.